Hello, my dear students. Today we are going to start a new chapter called electrochemistry. To study electrochemistry, we need to revise the last 10 standard point, which is known as the reactivity series. Reactivity series is the series of element in which the elements are arranged into the decreasing order of their reactivity. So, potassium, then sodium, calcium, magnesium, aluminum, zinc, iron, cobalt, and lead. These are the metals which displaces hydrogen from their salts or from their acids, and that is why they are more reactive than hydrogen. And then the less reactive hydrogen are copper, mercury, silver, gold, and platinum, which do not displaces hydrogen from acids. This is how the reactivity is formed. We know that in the reactivity series, more reactive metal displaces less reactive metals. So let us understand one displacement reaction. Zinc when added to copper sulfate, zinc solid when added to aqueous solution of copper sulfate, we get zinc sulfate aqueous and copper is released in the solid form. Now if we study the same reaction into the ion as an ionic reaction, zinc solid reacts with Cu plus 2, like this is Cu plus 2 and SO4 minus 2. So reacts with Cu plus 2 ions. Zinc solid is turned into Zn plus 2 and Cu plus 2 is converted into Cu solid. So you can easily understand that zinc is converted to Zn plus 2. This is a oxidation reaction, and Cu plus 2 is converted to Cu solid. This is a reduction reaction. So here this is a redox reaction. This redox reaction takes place by its own. We don't need to apply any kind of force from outside, and that is why this kind of reaction is considered as a spontaneous redox reaction. In this spontaneous redox reaction is made up of two reactions: oxidation half reaction and reduction half reaction. So now we look at the oxidation half reaction, which is also known as the anodic oxidation. So at anode or in oxidation, zinc is converted to Zn plus 2 and two electrons are moved. This two electron actually moves from anode to cathode, my dear students. So this two electron goes to cathode, where in like they react with Cu plus 2 ion present at cathode and turns them into the Cu solid. This process is known as cathodic reduction. Overall, if we write the chemical reaction, this two electron and t electron get cancelled and we get an overall reaction. Zn solid plus Cu plus 2 is converted into Zn plus 2 plus Cu solid. As we know that electrons moves here, and that is why electricity is produced. So my dear students, using this spontaneous redox reaction, we can produce electricity. So here we can say that a device is developed that convert chemical energy of spontaneous redox reaction into electrical energy is called the electrochemical cell or galvanic cell. Sometimes it is also known as voltaic cell. So please remember this. Now we'll try to study it in detail and how it is formed and what are the various things that we need to keep in mind. So to produce such a half cell, we should have two forms of the element. One form is known as the reduced form, which is the solid rod of metal, which is generally the metal rod, and then we need to have the oxidized form, of metal. That is what we are in requirement of. This oxidized form of metal is nothing but the aqueous solution of salt containing metal positive cations. So we have two forms, reduced form and oxidized form, and then these metal positive cations are kept in contact with each other and then from outside by conducting wire. So both the reduced forms are joined by the connecting wire, and both the oxidized forms are connected by the salt bridge. So kept contact with each other, and then from outside conducting wire is used to join the half cells, and inner side salt bridge is used to connect two half cells. According to the convention, the half cell kept left side is anode where oxidation takes place, which is a uh, negative electrode actually, and half cell kept in right side is cathode where reduction takes place, and it is the uh, positive electrode. So we can remember this as a left side anode oxidation, negative LOAN. So here you can see that we have given the same into the example with the Daniell cell. You can see that you have zinc ZnSO4 Zn plus 2 ion solution, which may be ZnSO4 or ZnCl2 or ZnNO3 twice, whatever, in which the zinc rod is placed. Same way we have the copper sulfate solution or CuCl2 solution or CuNO3 twice solution, and that solution is dipped with the copper rod. You can see this copper rod, which is the reduced form, and Cu plus 2, which is the oxidized form. Both these electrodes are joined by the conducting wire. In between we have put the galvanic cell, which shows the direction of the current, and then we have the salt bridge, which is kept deep into the both the solutions. So this is what it is known as the salt bridge. Here you can see that at anode there is oxidation takes place, which is written as Zn oblique Zn plus 2, and at cathode where the reduction takes place, which is written as Cu oblique Cu plus 2. Now let me try to explain the same. As we have already seen here, my dear students, that at anode oxidation takes place. You can see here anodic oxidation. So at anode what happens, zinc is converted to Zn plus 2 electron, and at cathode this 2 electron moves towards cathode, and this Cu plus 2 ion is converted to Cu solid. So let us understand the same here. You can see that in the anode, from this zinc rod, Zn plus 2 ion comes into the solution and 2 electrons are produced. This electron moves through the conducting wire via galvanic cell and reaches to the cathode. Here in the solution, Cu plus 2 ions are present. They get these 2 electrons and they are deposited on this cathode as a Cu solid. To maintain the ionic balance, we have the salt bridge. So salt bridge maintains the ionic balance and allow the ions to be balanced in both the solution, and it also provides the contact between the two solutions. So this is how, my dear student, we can understand the functioning. When two half cells are connected, the flow of electron is from negative to positive, from anode to cathode, left side to right side, while the conventional current flows from positive to negative, from cathode to anode, as shown in the figure. If you look at this figure, you can easily understand that the current, this is what we consider it. Look at this, my dear students. Electron flows in this direction, whereas the current, which is also known as the conventional current, moves in this direction, that is from positive to negative. So this is your negative electrode, and this is the positive electrode, which is known as cathode. So this is what it happens, and we get the conventional current. The same I have written here, that we have the direction of current is shown by the galvanometer, which is G. In place of the galvanometer, if we join voltmeter, we will find that if the concentration of Cu plus 2 aqueous solution and Zn plus 2 aqueous solution is 1 molar, or which is the maximum of 1.1 volt of electrode potential or EMF is generated by the cell. So we have been studying the galvanic cell, and this galvanic cell, which is made up of zinc and copper, can produce 1.1 volt of the EMF using, if the concentration of both Cu plus 2 and Zn plus 2 is 1 mole per liter or 1 molar. It is noteworthy that during cell reaction in anode, the mass of zinc rod decreases, and in cathode from Cu plus 2 to Cu plus 2 ion are deposited on Cu rod, and thus the mass of Cu rod increases. As we already know that from zinc rod, zinc ion goes into the solution, so the mass decreases, and copper ion deposited on the rod, so the mass of copper increases. At the same time, the blue color of the solution Cu plus 2 also fades, means decreasing. The intensity of color decreases, and at the last it turns into the colorless solution. From inner side, salt bridge maintain the ionic balance. In place of galvanic cell, if we join battery and apply voltage greater than 1.1 volt. Remember, my dear students, now we are bridging, like now we are uh, removing the voltmeter even, and now we apply, now we'll join the battery there, and we will apply the voltage more than 1.1 volt. So now we'll apply the voltage which is more than 1.1 volt. The cell reaction is reversed, and means the reverse reaction takes place. That means the Cu rod releases Cu plus 2 ions and its mass decreases, and Zn plus 2 ions are deposited into the zinc rod, and thus the mass of zinc increases. So instead of that, now the reaction takes place Zn plus 2 plus Cu, it gives Zn solid plus Cu plus 2, and this process is known as charging. So the first reaction that takes place when spontaneously, without any effort, due to which the electricity is produced, is known as discharging. And this process, when we from outside, when we apply battery and the reverse reaction takes place, this process is known as charging, my dear students. Thank you.